Hello, everyone. Welcome to today's webinar. Today, we're going to be presenting on partner primary storage solutions with AWS APN Partners. I just wanted to remind everyone of a few logistical things. We'll have the chat feature available to anyone who needs to put anything into the chat. We'll also have the questions you'll see on your control panel. We'll be taking your questions at the end of the webinar. So if anyone has any questions for today's webinar, please make sure to put those into the question panel. We should also have a short survey after the webinar today, so please remember to fill out that survey. My name is Henry Axelrod. I'm a partner solution architect at AWS, and I'm going to be joined today by Alessandro Menegas, who's a IT manager at Trey Altameda. So let's go ahead and get started. Okay, so first I just wanted to talk a little bit about the Amazon Partner Network. So what the Amazon Partner Network is it's a program that AWS provides that helps our partners build successful AWS-based businesses and provide valuable technical and marketing support for them. It also, from a customer perspective, enables customers to really get and identify high quality partners that they can work with on their journey to the AWS cloud. We have two types of partners that we work with, which are consulting partners. So these would be your system integrators and global system integrators. The consulting partners kind of help you as you're, migrating, building, and optimizing, and even running your workloads on the AWS platform. They often work together in conjunction with our technology partners, who are our ISVs or software providers and our hardware providers to implement their solutions on the AWS platform. They bring expertise of how to utilize the platform and help you on your journey. The technology partners, as I mentioned, are our software and hardware partners that offer a wide range of their services on the AWS platform, integrating with AWS. Now, what are some of the reasons you might work with an APN partner? They provide really value-added software, across almost any use case that you might have to use on AWS or with AWS. We're going to be talking about a few of those use cases in a moment, specifically for the storage partners. They also help you to accelerate your engagement. So they give you that level of expertise, as I was mentioning, with the consulting partners, where you can get up and running very quickly. So you can, even if you're starting without necessarily a level of internal expertise in AWS, these partners already give you that step up and kind of acceleration. And they also allow you to have, optimized architectures. We work with our technology partners to follow a lot of the AWS best practices and well-architected frameworks to make sure that they're constantly driving towards providing the best solutions to our customers. So as I mentioned, there's many different use cases that APN Partners and can enable on AWS. Specifically the APN storage partners work across 4 different use cases, which are primary storage, backup and restore, archiving, and business continuity and disaster recovery. Today, we're going to be focusing specifically on the primary storage use case, which enables customers to leverage file block and object solutions to run their primary storage workloads on AWS or integrate their on-premise primary storage solutions with AWS. So one of the key factors of the storage solutions that our partners utilize is that they use the AWS storage services as the building blocks of those solutions. And AWS offers a wide range of services. In storage specifically, we offer services across, object with our familiar platforms like the Amazon Simple Storage Service or Amazon S3, as well as Amazon Glacier for archiving and long-term retention. We offer block services like our Amazon Elastic Block service, as well as our Amazon EC2 Instance Store, which offers local ephemeral storage. We also offer file services where Amazon Elastic Files service, which offers NFS managed NFS shares. We also offer a wide variety of data transfer services that help you get data from and to the AWS storage services. Services like Direct Connect, which provides a connection directly from your data center or co-location facility to an AWS region with dedicated 1 or 10 gig bandwidth, as well as services like the AWS Snowball or Snow Family, which offers ruggedized devices that get shipped directly to your facilities that you can load up offline, and even utilize compute services offline to process pre-processed data and then send that to AWS to get loaded onto Amazon S3. Without the need for having dedicated network bandwidth for that, or even having a network connection. Now, when we talk about primary storage, we're going to look at a few of the architectures that are involved in our primary storage with AWS. So the primary storage use case allows for all sorts of connections, and we're going to look at each of those architectures in more detail. So the first architecture that we'll look at is the architecture where essentially we are emulating on-premises storage. So, this is where, file protocols are provided in a similar way to what clients are normally expecting from an on-premises perspective, such as, NFS and SMB on the front end, while on the back end, the actual data is able to be stored on Amazon's highly durable and scalable storage services like Amazon S3. That can be done over a wide variety of connections, and it's a very common use case for customers as they're starting to adopt services on their cloud journey, but may still have compute presence in their data centers. The next architecture that we're going to look at is the distributed file architecture. In In this architecture, the file distribution use case provides uh, access for files across multiple physical or logical locations. File distributions can provide NFS and SMB shares, but they go beyond the boundaries of a single data center and can utilize Amazon S3 as a backend, enabling files to be shared across data centers, and even enable global collaboration on files without having to make many copies of the same files, manage that distribution on the back end. The next architecture that we're looking at is file storage service, where the partner solution would be located at a co-location facility and have dedicated direct connections back to the customer's VPC, or virtual private cloud, on AWS. What this allows is for customers to utilize this storage solution that provides fast access and is able to allow customers who are running their workloads on AWS to access that storage, both with or without the on-premises connection. The next use case that we're going to look at is a replication use case. And in this use case, there's certain partner solutions that run on AWS in a very similar manner to how they run on premises on Amazon Elastic Cloud Compute, Amazon EC2. These are generally AMIs. They're deployed either directly or through the AWS Marketplace, and use native protocols to synchronize data from on-premises storage arrays to arrays that are running on those virtualized instances on AWS. So it would be similar methodologies to how those arrays normally replicate when between two on-premises facilities. So customers are able to use the same administrative and techniques, even potentially some of the same automation that is used when going to a secondary site from these arrays. This enables customers to easily extend and expand their capabilities to AWS, and be able to utilize a familiar administrative interface as well as familiar features. Then we'll take a look at the next architecture, which essentially is a data movement architecture. So in this particular architecture, files would be moving from a on-premises location where they may be stored on a file system, again, that may be shared out via NFS and or other IP protocols such as SMB. And they would actually get transitioned to objects. So the syncing would be, and the translation would happen automatically by the partner synchronization protocol, and would take those files, translate them to objects either as a one-time migration or on an ongoing basis, and would allow access by the various AWS services that are able to talk to Amazon S3. As you can see, several of those services are listed, and this enables legacy file shares to be accessible by advanced services that allow things like data analytics and machine learning. The next architecture, or the last architecture here that we're going to look at is essentially replicating from similar to the last architecture we looked at, is replicating from a local object store to Amazon S3, or even tiering from a local object store to Amazon S3. So somewhat similar to the last case, but instead of the source being a traditional file share, NFS or SMB, if there is a partner solution that is running a local object store on premises, they're also able to, on the back end, talk to and store objects in Amazon S3. So on that, we're going to take a look at a few of the partner solutions. The first solution that we're going to look at is Wekalo with their product called Matrix. Now, Matrix is a parallel scale-out NAS that's completely software defined and runs in containers on the AWS platform. It's designed to be very highly performant and takes advantage of our local instance storage to provide high-speed all-flash storage. It also is able to utilize cost efficiencies by offering tiering to Amazon S3, where you can tier, part or the whole data set could be snapshotted to S3, allowing the cluster to be brought, offline or online, or share data, across different regions, or even between on-premises and AWS. It offers linear scalability, so as you add nodes, you increase, both the performance and capacity. So one of the customers that is utilizing Wekalo is a big online e-commerce provider, and they were previously using Objective-FS and found that it didn't really meet the consistent level of performance that they were looking for. So they decided to run Wekalo and the Matrix FS, as I was mentioning, on AWS. They utilized 6 instances to run it, but they had over 140 application instances, which is an important thing to note about this solution. Is since it is a distributed parallel file system, it can be sized and run separately than the application workload. So the application workload can be run on many hosts, and often is on just a small amount of Weka nodes, depending on the particular performance level that is required. It can also run in a hyperscaled mode, which can run alongside with the application and as a container. So what they were able to achieve here was, extremely low latency performance, and really a big savings over Objective-FS, since Objective-FS is licensed by the clients, and since they had many more clients than they had actual storage nodes that they needed to run, they realized huge savings here. And that's some of the benefits that running these type of solutions can provide. And I'm glad to have with me today Alessandro, who's the IT manager of Trey Altamira, who's going to share a little bit more about the very interesting use case that that Trey Altamira is doing with Weka and AWS.
Thank you, Henry. Can you hear me? Yes. Okay.
Yes, you're good.
Okay, perfect. Thank you. Trey Altamira is the world leader in measuring ground and structural movement using satellite radar data. The measurements that we provide are used widely in several market sectors, including oil and gas, mining, civil engineering, and geohazards. We exploit the images acquired by the radar to analyze the movements on. Let's go ahead with the slides. Just a moment. Henry, can you give me the control of the presentation? Excuse me, Henry. Can you give me the control of the presentation?
Yeah, you should have it.
Okay. Anyway, we exploit the images acquired by the radar to analyze the movements on the areas of interest for our customer. Trey Altamira played a key role in some well-known projects like Grand Paris Express, Canada Line, and many other monitoring projects in the oil and gas and mining markets. For example, in California, we are the reference monitoring provider for Chevron's oil fields. Our input data are provided by many space agencies, including NASA, Canadian Space Agency, European Space Agency, and several others. The input of each of the analyses provided to a Trey Altamira's customer is a dataset of satellite information that could take more than 4 terabytes for each analysis. Trey Altamira's internally developed software processes this input data on a Linux HPC cluster to produce our deliverables. I can have an example, but I don't know if we can go ahead with the slides. Anyway, our software implements a processing chain of more than 100 steps, some of which are made of thousands of parallel jobs that needs to access the input data and the partial results of the previous steps at the same time. For this reason, each analysis requires significant processing power and a high-performance storage. These factors have a strong impact on our business since they determine our production capacity, our time to market, and our innovation capabilities too, since we couldn't consider new products or services that would require too many processing resources. Till last year, all our results were produced on our on-premises data center. So the three factors on the right were limited by the number and the power of our machine and by the performance and the capacity of our storage. Just as a reference, our on-premises storage is a 300 terabyte system that provides a 5 gigabyte per second bandwidth toward the Linux cluster. The production capacity, for example, was limited to 30 analyses per week, so we simply couldn't accept more orders than the ones compatible with this number. Or we had to extend the delivery time. Sometimes it took more than 3 weeks to produce a result simply because all our resources were already in use. These limits surely didn't encourage the innovation, and sometimes in the past new promising algorithms have been discarded due to the lack of resources. This situation was aggravated by the nature of our business that is based on orders which arrive with a very variable frequency and with a myriad different requirements in terms of number of analysis requests. This scenario can lead to highly variable workloads, and highly variable workloads mean that it is very difficult to optimize the size of your infrastructure. If you size it on production peaks, you're going to waste a lot of money during non-peak periods. We knew that cloud could be the answer to this problem since it can provide both the power and the scalability to manage variable workloads. But we had more than 500,000 code lines developed in the last 20 years. This code has been strongly customized for our on-premises infrastructure, and for this reason, a translation of everything to exploit the cloud-native services would have required human resources that were not at our disposal at the time. That's why we followed a pragmatic approach, moving our production on cloud with a lift and shift strategy. Looking for cloud providers, we considered the three main players. We choose AWS mainly because of the depth and the breadth of service offerings, the ease of use, the scalability, and the cost economics. Specifically, AWS has a CFN cluster that is a framework that to deploy HPC cluster on EC2. And this framework helped us to adapt our software very quickly and to speed up the learning of the new platform. Moreover, our survey of the cloud's technologies showed that AWS could offer several alternatives for the storage, as mentioned by Henry. Nevertheless, our requirements in terms of performance were not so standard, so we didn't find many case studies similar to what we intended to achieve. So even if we decided to proceed with AWS, the only way to identify the correct solution for the storage was doing some tests of the available options. We decided to test a solution similar to the ones that we used in the past on premises, a well-known parallel file system called Lustre. The configuration of the software was very difficult even using the marketplace version of the file system. In fact, we had to install the Lustre client on our custom MEI that is based on Ubuntu Linux. The installation required some time since Lustre was not officially supported on Ubuntu. And even if there are several companies that are using this setup in production, the installation required the sources compiled, and we had many compiling errors to solve before having a working version. Anyway, after the installation, we tested the file system for 2 months before discovering that under heavy workloads, the file system showed an unstable behavior for our application. Launching thousands of parallel jobs on dozens of EC2 instances, the performance of some machine dropped down from 80-90 megabytes per second to some bytes per second. This problem was probably related to the sources compiled, but changing the operating system and retesting everything was not an option for us. We tried to ask some help to Amazon, and AWS solution architect mentioned Wekalo as a possible alternative. So we developed a solution that you can see in this slide. You can see the macro blocks of the solution that we developed integrating Wekalo. Our automatic deployment chain starts from the deployment of the file system in the first block. The Wekalo Matrix FS runs on AWS EC2 instances. In particular, we use i3.2x large instances, but there are other options that we are currently testing to optimize the overall solution. The Wekalo software combines these instances, creating a single storage cluster for the dataset. This phase has been very easy to implement, as you can observe from the few bash instructions reported on the right. This example creates a 21 terabyte file system with a 10 gigabyte per second bandwidth. Using an online calculator available on the Wekalo website, starting from these requirements in terms of size of the file system and performance, you can evaluate how many EC2 instances do you need to launch. In this case, as you can see from the spec variable, we have to launch 17 i3.2x large instances. This was not the only option proposed by the calculator, since it proposes several different alternatives, and for each of them, it estimates the total hourly cost. Anyway, and once you define the spec of your file system, you can generate a CloudFormation template through a web service provided by Wekalo. And with the third instruction, you finally create your Wekalo cluster using CloudFormation. The second macro block deploys the processing cluster, basically using AWS autoscaling groups and the custom MEI that already includes our software libraries and the Wekalo client. I have to mention that installing the Wekalo client on our custom MEI has been very easy, as you can see from the instruction on the right. You only have to download the Wekalo cluster, extract it, and launch an installation script. It takes care of everything and it completes the installation in a few minutes. Wekalo has a wide compatibility matrix, and we tested it on 3 different major versions of Ubuntu without any problem. After installing the software, with the last 2 lines, you add the instance to the Weka cluster and you mount the file system. The ease of installation is something we had never experienced in the past. In the last 20 years, we tested and used in production several different software solutions for the central storage. GFS, for example, GPFS, PANFS, Lustre. Since the setup and the upgrade of these products required a long planning and testing phase, we were always reluctant to proceed to the upgrade. And sometimes this state of mind has been sort of a break for innovation. Having said this, in the last 6 months, we upgraded the Wekalo 8 times, and each time the provisioning of a new custom MEI required less than 30 minutes. So, as you can see with Wekalo, this component is not slowing down the innovation process anymore. Actually, it is pushing us to evaluate new features and improvements of the file system as soon as they are released. After deploying the Wekalo storage and the processing cluster, we just have to launch our software in the 3rd macro block. And after some hours, in the 4th one, we collect the results, archive them on S3, and shut down the whole HPC infrastructure. The benefits that we got from this solution are many. First of all, we removed any production capacity limit. Each analysis runs on a dedicated HPC infrastructure. For example, the processing of the whole United Kingdom on premises would have taken more than 2 weeks, and it would have required all the available resources, so we wouldn't have been able to process anything else during that period. But we couldn't block all the other orders for all that time, so a whole nation processing was something we simply couldn't do, or at least we couldn't offer that analysis as a standard product. On cloud, the same UK processing can be completed in less than 2 days without blocking anything else. We could also process more than 1 nation at a time, and each run would not influence the completion time of the others. A second big benefit of this implementation is about cost. The costs scale linearly with the workload. If we have no running analysis, then we are not paying anything. And this is great if your business is characterized by very variable workloads. Relative to the time to market, we completely removed the dependency from the number of concurrent analyses. And execution now takes 12 hours on average, regardless of how many orders are in the processing phase. This improvement has been really important for many reasons. First, the sales process is much more simple. The salesman can guarantee the delivery time to the customer without checking the load of the data center. Secondly, it simplified the organization of the production process. In the past, we spent many time and resources to manage the concurrency and to estimate the delivery times. Last but not least, the Wekalo solution on AWS opened the new areas of innovation for CTERA Altamira. Products and services that have been discarded in the past by us due to the lack of resources are now feasible with AWS and Wekalo. We went from the processing of cities to the processing of whole nations, and these are only, and in the next slide, Henry, can you go ahead with the slide? Anyway, you are seeing the first nation that we processed. Now the nation scale is a brand new product, and we are the first in the world to provide this kind of service. A second service that is going to be greatly improved in the next few months is our continuous monitoring product. This service provides a new update after each acquisition of the satellite on a target area. In the past, we could provide this service only for a few very small areas and only with very relaxed service level agreements. In the next few months, we are going to extend this product, providing a proactive service that will be potentially very helpful for the monitoring of areas that could be interested by movements. For example, let's think about landslides, oil fields, bridges, and other similar infrastructure. Our future plan. Well, first, we are already executing lots of tests and benchmarks to optimize the Wekalo performance for our application. We started from the lowest cost solution, but maybe it is not the best one, since a better performing instance type could lead to shorter execution times. And even if, even with a higher hourly cost, you could spend less for the same analysis, or you could pay the same price to have the results earlier. And this test could also help us to identify different execution modes that in the future could be chosen on the basis of the requirements of the particular execution. Sometimes you need the results as fast as possible and you're willing to accept a higher price for it. Sometimes the time is not so important, so maybe you prefer a solution that minimizes the costs. This means that our deployment chain could adapt to different requirements to provide the best trade-off between cost and performance for each case. Since Wekalo can provide great performance in terms of bandwidth and IOPS, we will modify our software to exploit more these capabilities. The most compute-intensive steps of our software are already run in parallel, but the parameters that rule this parallelism have been defined for storages that have narrower limits, so there is plenty of space for further optimize our application. Finally, we haven't explored all the features provided by the Wekalo file system yet. One of the most promising is the one mentioned by Henry, the tiering on S3, that is the possibility to create a very big file system with a relatively small high-performance tier, and that is located on the Wekalo instances, and a big cold tier that is located on S3. Your application can see the whole size of the file system, but the costs are reduced significantly since you are exploiting the S3 low prices without giving up the performances of the Weka file system. Thank you.
Thank you very much, Alessandro. That was a great use case and great to hear, you know, how you're getting that that benefit and have those great plans with utilizing Weka on the AWS platform. Let's continue to talk about a few other solutions as well that our partners provide. The next solution that I wanted to talk about is the CTERA solution. Now, CTERA enables you know, enterprises to transition from traditional file storage systems to a cloud-powered platform that modernizes how users, you know, store, share, and protect, as well as govern their files. CTERA can help, you know, simplify remote office infrastructure, you know, improve productivity and collaboration, and extend to a wide range of enterprise file services, you know, which enables customers to have workflows like enterprise file sync and share, from which allows them to connect from a variety of locations and store their files on the you know, cost-effective, highly scalable, and highly durable Amazon S3, as we discussed. One company that's doing this is a large private equity firm that many of you may have heard of, which is called the Carlyle Group. So what they were doing, they had a Windows environment where they had you know, file servers among other servers, and they were, you know, looking for, you know, a way to you know, to share files across the globe. It was, too difficult and slow to do that with their local file servers. So they end up deploying CTERA and tying to Amazon S3, and they were able to really modernize their file services and actually add some business continuity and disaster recovery at the same time. So this kind of not only reduced their costs, reduced their complexity, and gave them, a way to easily and centrally manage, a single, authoritative copy of their data, across those several different locations where they need to deploy this. The next solution, is a similar solution called Panzora, and Panzora is, provides a a kind of multi-protocol gateway that allows your data to be stored again on AWS in Amazon S3, and it provides not only global access to your data, but global deduplication and compression, allowing cost savings across duplicate files anywhere within your overall file storage. So it allows you to collaborate around the globe again, and access the same files across many different sites. So the one thing that Panzora enables that that customers find useful is a global locking feature, so that files being updated anywhere around the world could get protected against multiple users writing to the same file, so that that file lock is not only locally within the data center where that file may be accessed, but it's anywhere that file is accessed via any of the Panzora systems, either on the edge or running within the AWS environment. So it gives you really, that kind of ability to have true global collaboration without having to worry about data consistency, and gives you a true global namespace for all your data. Now, in the case from a customer's perspective, this particular customer that utilized Panzora is a large media company that was looking to do collaborative work on a big theme park project that they were working on. They needed to ensure that they had, version management and could deal with any kind of, conflicts that might happen with that global collaboration. So what they were able to do is to implement the Panzora solution, and without really changing how their workflow utilized, since they were able to utilize the same protocols and access via the same methods that their applications and users were used to working with, they were able to fully deliver that project on time and reduce cost, as well as, since their data was durably stored in S3, they help reduce some of their complexity with backup and disaster recovery, as well as simplified how they were, they handled their data security and governance policies. since they didn't need to maintain, several different file servers, and they can now rely on the same source of truth. The next solution would share is the Qumulo solution and their QF2 product. Many of you may be familiar with this product as well. It's also a scale-out NAS system that runs both on AWS as well as on premises. It provides a scalability by adding additional nodes and providing multi-protocol support for clients. It utilizes a continuous replication methodology, which could replicate data between on-premises and AWS, as well as between different regions in AWS where it would be running. So this enables many different use cases. Everything from machine learning to media and entertainment, as well as even medical imaging. It's very intuitive and easy to use platform, offering full REST APIs, as well as a simple, easy to use GUI, and even offers advanced metadata searching natively within the platform. So one company that utilizes this with AWS is FuseFX, and they're a visual effects company in the media and entertainment industry that work together with Amazon Video to help produce the TIC. Now, as is common in a lot of media and entertainment workflows, they needed to run large transcoding farms in which they need to spin up several a large fleet of render nodes to process their rendering jobs. So in this case, they utilized Amazon EC2 Spot, which for those who are not familiar with what EC2 Spot is, it allows you to spin up EC2 instances based on a specific bid. So you can get instances for significantly cheaper than the on-demand pricing. And those instances will spin up when your bid price is matched. So this allowed them to spin up, large amounts of compute to process, at the most cost-effective rate, and they were able to use Qumulo as the shared centralized storage for that render farm, which allowed them to, both save time and get, huge amounts of performance across that render farm, allowing them to also save a significant amount of cost versus having to build out that render farm on premises. The last solution we wanted to take a look at is NetApp. So NetApp provides a storage system called Cloud Volume ONTAP that runs on the AWS platform. I mentioned earlier the architecture using native replication. So those of you who are familiar with running NetApp filers on premises will know that there's a replication called SnapMirror, and SnapMirror will allow you to replicate volumes on your NetApp filer on premises to a NetApp filer that is running on AWS in a similar fashion to to how you would do it to a second NetApp filer. So it'll provide a very familiar interface. Also, the overall capabilities of the interface, providing both NAS and iSCSI to the various different applications and workloads that you would be running on Amazon EC2. Are made available, so you can create shares. There's no if you're running Cloud Volumes ONTAP, you can go ahead and create various shares on those instances and provide them out to your workloads running on Amazon EC2. So one of the customers running this is in the public sector. They're a Monash University. They're actually Australia's largest university. They have a large amount of student, staff, and facility across 4 different continents. So they were, like many companies that are on their cloud journey, they started with a cloud-first strategy. So new deployments would end up going to cloud, and they eventually were looking to move to a cloud-only strategy where everything would run on AWS. So they had to migrate quite a large amount of workloads within just a year's time frame. So they end up utilizing ONTAP Cloud as their storage platform on AWS. And they were able to reduce their overall storage spend by about 25%, and they were able to quickly spin up and tear down their environments and still retain their data. So it really enabled them to be successful in that migration. I just wanted to share with you a few additional resources that can enable you to find out more information. One is the AWS Primary Storage Competency Partner Solutions, on which you can find at this link, so you can find additional solutions from our AWS APN partners, as well as you can find on-demand versions of these webinars at this address. On that, I want to see if we have any questions. Remember, if you haven't already, you can put in your questions into the question box on the right-hand side. Any questions that we don't get to today, as we only have a few minutes to answer questions, we will be able to follow up with you on email directly. So please feel free to ask any questions that you might have. It looks like we have a few questions here that we'll start with. So the first question appears to be asking about VMware and how, let's see. So essentially want to know, how easy it is to migrate workloads or VMs to the AWS environment. So there's many different ways to migrate VMware workloads to the AWS environment. There in fact are many partners that specialize in migrations. Not part of today's topic, but we do. I would definitely suggest looking on the partner solution finder or the partner page that we just provided in the previous link to find migration partners that can assist. There's partners that can help with automatically converting those VMs to EC2 instances. We also there's also a service called VMC, which is VMware on Cloud, that provides some of the best features of VMware that's built on the AWS platform that can help enable seamless migrations from VMware to the AWS cloud as well. Let's see if there are any other questions here. So, Alessandro, I have one for you if you're still on.
Yes.
Yeah. So one question for you is, do you have any performance information on the on what you were able to get from the Weka cluster that you were running?
Yes. Right now we are creating file system with 4 terabyte for each analysis, and with that size we have a 10 gigabyte per second bandwidth. We measured that number with IOZone, with the tool IOZone, with the option, with the concurrency option. It took, if I remember well, at least more than 25 instances to reach that aggregate bandwidth on the file system.
Great. Thank you for that, Alessandro. So another question was, how can I find the right size for the Weka cluster? I think Alessandro also actually touched on this a little bit, but I'll also mention it that if you go to start.weka.io, that you can find information on exactly how to size a cluster. You simply specify your bandwidth requirement or IOPS requirement and your capacity requirement, and it will tell you exactly what your options are for the number and type of instances that you can deploy on the AWS platform. With that, I think we can only take maybe one last question. So I think this question of if the all the solutions we've seen, where can I get more information? So as I mentioned, the solution finder is one place where you can get additional information. Also, several of these solutions that you've seen today are available through the AWS marketplace, such as Weka, Qumulo, and NetApp, and they can all be deployed and tested directly from the AWS marketplace. On that, I want to thank everybody for their time and participation and for joining us on today's webinar. I want to thank a special thanks to Alessandro for sharing his story with us today on what he's been able to accomplish with WEC and the AWS platform. And any questions that we weren't able to get to, we'll follow up on email. Thank you again, and have a great day.